Alright everyone, now this is the first video where I'm actually going to be talking about plotting and a little bit more detail. Now note, I have already spoken, I've kind of shown plots already in passing, and you've seen the general workings of the plot function, but I want to go into a little bit more depth and then how you use MATLAB M files to call that. And there's actually a lot of ways to get your plots to look pretty and get the data to look exactly like you want. And my goal isn't to go through every single function here. I think there's a certain amount of exploration that I encourage you to go through, but I will show you some of the things that make life a lot easier here and how to work this. So the first thing I'm going to show you is, foremost, go to plots and you'll see all the options that you can do within MATLAB. You can do this graphically like you would in Excel and everywhere else, and it even kind of, as you hover over, gives you explanation of it, actually shows you the code that's associated with these. It's a very nice way of learning some of this. Now, of course, whatever you're doing in these values up here in these codes won't translate when you upload a homework assignment through an M file. So you want to learn how to do the M file coding of this. But for the sake of actually learning what these do, this isn't a bad first step. So I'm going to take the volume data that we had created in our mesh grid function, and you can see once you select in the workspace the variable, it opens up and you can actually collect or select different types of plot formats that you want to see to represent that data. You can get a contour plot, which is a top-down value of areas that are higher or lower, or intensity or values. You can get a 3D plots like surface mesh grid, semi-log plots, area plots, bar plots, plot plots, all you can think of. Click down and even get a larger sense of just all the different kinds of formats and things you can do here. And like I said, it would take quite a long time to go through all of them, but let's just look at a surface plot, or let's do a mesh plot on the volume data so you can see what this looks like. And sure enough, you can see how pressure, temperature relate to each other in this value. Now you'll notice right away these axes are meaningless because the way we selected this data, there is no value that represents what the magnitude of the one direction is versus the other. So this is sort of not the best way to set this up, and this is going to be some of the ways we're going to learn why you might want to use the other formats to have this program in and using the code. But you can see here, you can actually use the arrow, click here, rotate the plot to see different angles of what's being shown and so forth. And now if I wanted to, you even have the ability to go in and edit and view, insert. You can insert a label for your X, Y, Z, title, legend, and so forth, all through drop-down menus like you would anticipate in Excel. So this is all just very much a graphical user interface in editing plots. But that's not really what I want to show you today. I think this is very cool and it shows the use, but like I said, the advantage of MATLAB is once you program an M file, you run it, it will always bring up exactly what you want. And here, if you made a plot this way, you'd have to manually change it each and every time you did that, which is a little tedious and a little, I think, boring to effectively. So we're going to clear this data out, clear all of this, and let's go ahead and look at a MATLAB version of making a code. So I'm going to create a function. I mean, XY function, very simple. We're going to do very simple plots. Let's say X is equal to, we can say a variable from 0 to 2 pi. I'm going to go in increments of pi divided by 10, and let's do pi divided by 30, and let's do pi times 2. So that'll be our X value. Oh, did I not? Times 2. There you go. So we have an X value range, and clearly I'm going to, because I'm doing pi, I'm going to do something in the sine function or so. So I'm going to create Y, and let's call this Y1 as equal to sine of X. Okay, so we have that. Now, if I want, I can go ahead and I'm going to go home, create a new script, and let's go ahead and they're in the background. We can plot this by saying plot X comma Y. Now the plot function, if you look at it, takes several different forms, but undefined x, y1, there you go. Takes several different functions, forms. You can enter in data as, like we just did, where we have x as a single vector, y as a single vector, and it creates a whole new figure that is plotted over here. Now, if I wanted to go ahead and actually plot multiple figures onto one thing, I can do this in a couple of different ways. First and foremost, I could actually create a new plot, so a new figure, and say y2, new y data, and let's in this case say is equal to the sine of x times 2. Okay, enter. So now, if I go to help plot, it'll come up with several different ways you can see this. It can be inputted as x or y, where x and y are where is x is a vector and y is a vector, or x can be a matrix and y is a matrix. I can also here plot series of data, x1, y1, and this s1. S1 are the values that we'll talk about in a little bit, and x2, y2. So we can actually do this sequentially as a series of inputs. So I could say plot x comma y1 comma x comma y2, and we'll go over to my figure, and you'll now see that we have these two plots that are shown on here. And now there's a default set of data that's being presented here in MATLAB in these figures, and perhaps this isn't the default that we want to show. Maybe we want to show this as a alternative form, or maybe we want to show these as different figures and so forth. How can we do that? Well, to start off with, we'll go in the editor and start playing it from here, because I think this makes it a little bit easier to see what we're going to do. But in the figure of a plot, in the data, we can say plot, and I can go ahead and say x comma y1, x comma y2. Now, what are some of the formatting I could do within in this? Well, if you notice, I can first type in title, and I can give our value a title. Now, in the title function, it's going to edit whatever is the active figure that's in place. So by creating a new plot, we just created a figure that is our active figure. And so we can call this title, and in this title, I can call this sine functions. And the apostrophe here, the apostrophe before and after, specify that this is a text field that we're entering in. So that's one thing we can put in. We can also, there's an x label function that we can do, which is going to clearly label the x function. So we can say the angle in radians. And here, you can say y label. You can say this is just the y-axis, or whatever we want to call it. And we can label this function appropriately. So I'm going to save this, save as, and just call this figure plot. And that's invalid, so we'll say figure plot. And now we go to our figure over here. I'll bring this up, and I will run this. You'll now see that we have our figure with our angle, sine function, and x-axis labeled appropriately. Now, there's so much more we can do with this, and actually you can get a sense for a lot of this if we do again help plot, and oh, it's actually already up there, so I won't do that. But you can see also, and look at what the other options we have here: plot tools, title, x label, y label, axes, axis. This starts to give you a sense of what some of the things we can do with these plots. But let's go back and show you a little bit more. Let's say, for example, in this, I'm going to want to plot a series of values, but I want to to not plot a solid line anymore. I want to actually plot circles instead of like for data points. And I can do that here by changing the plot format. And you'll notice here, this is kind of gives you an example of what this looks like. You can specify x and y, the variable, and then right after that, using the string command, you enter in what you want it to look like. You enter in a color code given by a letter, a line if you want it to be a line, a circle if you want it to be a circle, or it can be a combination of the two if you want both a line and a dot. So, with all that said, let's go back to our data and let's do something non-default. So in this case, I'm going to say the first one I want it to be blue circles. And let's look back at the code because I don't anticipate us memorizing these. And it's completely acceptable to just remember. And I'm going to have this one be dotted lines. And so let's make this one comma. Let's make it black, which is K, and dotted is a colon. Do that way. And we can click run. Go back to our plot. And you can see very nicely that we have a dotted line and the circles given here. And like I said, once this is coded in, anyone who runs it from their machine will get the function that looks exactly like this on their own machine appropriately. So it's a very nice way of getting plots of different kinds onto your series, onto your system. Now, there are a lot of other ways of looking at this that's of use. For example, maybe you don't want, or maybe you have multiple figures you want to do in a single plot or a single M file, and you don't want it to overwrite, because look what would happen if, for example, I said we had one plot that was going to be our sine function that we did, and so I'm going to clear CLC. So now I am going to go to our M file and code in exactly what I want to have happen here. So I'm going to create x as equal to 0 to pi divided by 20, and go to 2 pi, and then y1 is equal to sine of x, y2 can equal to sine of 2 times x. Great. So we have that. Now let's say we wanted to create another plot. Let's say we wanted to have a third figure where y3 is equal to exponential of negative x times 10. And let's say this one is going to be negative x 0.5 times x to 10. Okay, so that's going to be the range we're going to look at this for. And so let's say we wanted to create a new plot. I'm going to just copy and paste all of this, and we are going to say, now I'm just going to make them default figures now. I don't want this to be there. I don't want this to be there. So I am just physically simply limiting this, and I'm going to replace y1 with y3 and with y4, 3 and 4. So I'm just creating two separate plots for two separate data sets using the same x value. If I click run, what you'll find here is we have a single figure titled figure 1 that's still, it's still called sine functions. I should change that title. I'll do that in a second. But you'll notice it's the actual exponential decay values here, and we lost this entirely because it overwrote our figures. I'm going to change this title here to exponential functions, and this is just x and y-axis. Okay, so how do we prevent that from happening? Well, we actually have the ability to define an active window with the figure command. Figure with the value of 1 specifies that this is going to create a figure 1 as the active figure, and it's going to do all these things within that active figure. If I wanted to create a second figure that's going to do all these other things, I just type in figure 2 and create a second figure. So now if I click run, we'll have 2 figure windows pop open, each of them with the coding that was specifically tailored to them. And we have that ability as well. Now, that may not be the only way you want to do this. Alternatively, you can actually take and do what they call a figure hold, where if I did, where instead of just simply having the figure write over, because any new thing that happens in that figure, for example with plot, it'll just write over it. I can hold the plot, and this hold means that what the active figure is being held. If I click run, it says current plot held, and now you'll see both of those figures or both of those functions are happening on one plot now, and it will remain that way. Every time I repeat this, every time I do something new, more and more stuff will happen into this plot until I release that plot. And if I type in hold again, it turns it off. So hold is really a command that kind of is a on-off switch. You do it once, it holds it. Do it a second time, it turns it off. And so that's another way we can get around a lot of things we can do in MATLAB to start to edit these things through and kind of make multiple figures look really pretty and clean and nice. Now, one final point that I want to highlight, and so I'm going to close this figure X. I'm going to current plot, make sure it's hold, current plot held, hold off, it's released. We're going to close this figure. So you'll notice we have y1, 2, 3, and 4 as 4 separate vectors, and if I did plot x, comma y1, x, comma y2, x, comma y3, x, comma y4, and enter that in, we can get all of them one plot in one go. That gets a little redundant. Alternatively, we can actually have a single x, and if all the y's are in a single array as data, we can actually use that to our advantage to create a single x versus an array of y's and have those plots appropriately. So in that case here, I'm going to create y'all is equal to y1, y1, y2, y3, y4, and oops, that's not the way I wanted to do it. You'll notice by doing it that way, I created all of them in a single, it's a single column, a single row of values. I just stack them all into one thing. I want them to be 4 separate rows. So let's change that with semicolons. And there we go. Now it's arrayed in the right way or format that I'd like. I can click plot x, comma y, y'all, and it will create this value appropriately for our system. Now, one of the things I'm going to show you really quickly, and this is the final point on this video, and this is why you always have to try to play with it a little bit to make sure it's doing what you think it should be doing, is MATLAB is pretty good, but it's not perfect in determining what you want. You'll notice here, because it's 4 by 1 and these dimensions match, it's going to fix it so that it's plotting these matched columns with these matched columns in this array. If it wasn't matched, so for example, I can flip the dimensions on y'all by using the apostrophe. That's a transpose feature, and you'll now see it's 41 versus 4. Now if I plot this, x versus y'all, and you look at it, it still has it correct. And that's because it's smart enough, the plot function is smart enough to check for dimensions and then orient it so that the y's are going to line up with the x's in the appropriate way. This is great as long as the dimensions are not uniform. If perhaps this was a 41 by 41 array, it's not going to inherently know which dimension is a is all the y's that are represented, and which dimension are the different treatments or the different types of values. And that's a critical point because you want to make sure that it's plotting the correct orientation and not the wrong orientation. So just make sure that as you use these MATLAB functions, oftentimes it'll fix your mistakes. Small ones are easy, but other times it doesn't know which one's the right way and it will get confused. So always double check your results in that way. Well, we'll stop here, and in the next video I'm going to talk about actually putting on subplots and some other examples of nesting plots in more elaborate ways. So thanks a lot.